All right. Welcome to this week's Megaport Live Tech Drop-In. This week, the topic is AWS Direct Connect. We're basically going to do a bit of an overview of Direct Connect, very briefly, just sort of what it is to set the scene, and then we'll move to how it kind of works, what the components are, how the architecture fits together, and then some of the gateway options and different designs that we typically see. So we'll start off as usual with a bit of an overview of Megaport and network as a service, how that fits together, where Megaport kind of fits into the picture, and then we'll go on to Direct Connect. We'll run through the different components that make up Direct Connect and what the architecture looks like, how those components fit together, and then a couple of the different gateways that are involved with Direct Connect and some of the ways that it gets deployed, some of the different ways that it can be used. We'll then jump into a demo and Q&A as well at the end if we happen to have anything come up that we haven't addressed as we go. So Megaport is a network as a service provider. Basically what that means is Megaport runs a very large global private network in, it says 800 plus data centers here, but it's a few more than that now. Basically, we have points of presence built out in loads and loads of data centers all around the world, and we build a private network between them. So somewhat in the way that a carrier would. The difference is that we provide access to that network in an as a service, on demand, flexible, scalable, API driven kind of way. So we build the same types of resources as some carriers do, some telcos do. We have this very large global network that we run, but we productize that. We provide that to customers in a way that aligns with cloud providers and the way that you would buy compute from someone like AWS or Azure or Google Cloud or Oracle. So it's on demand. You basically create what you need when you need it. It's flexible, all that kind of thing. All those things you would expect working with cloud services, but for the network as opposed to for compute. So the idea is basically you connect to Megaport's edge wherever you are. So if that's in a data center, we have some virtual connectivity options as well. So you're physically plugged into Megaport's network. And then you can spin up connectivity and network services over that network around the world to whatever it is you need to connect to. So one of the really common use cases for that is to connect to clouds. There's lots of other use cases as well. So customers use this to connect between data centers or B2B stuff between customers and providers and all kinds of things. But one of the common use cases is to connect to public clouds. So we have all the public cloud providers available in our network, which means we have physical connectivity to those cloud providers already in place that you can just spin up circuits over the top of. So you don't have to go through the process of ordering separate dedicated cross connects or LOAs or all that kind of thing. And that's what we're going to get into today. So Direct Connect is one of those services. Basically, the way that we connect to all the cloud providers is via their private connectivity services. So Direct Connect for AWS, ExpressRoute for Microsoft Azure, Google Partner Interconnect for Google Cloud, GCP, Fast Connect for Oracle Cloud, and so on. So we physically plug into all of the clouds via those services. And so what Direct Connect does, along with those other services, it means that you're not using the public internet to access these cloud providers. You're not using virtual tunnels or things like that over public internet connections and sort of open areas. You're physically connecting. You've physically got a cable that's plugged into the edge of AWS's network. So physically in a data center somewhere, there's a network device that belongs to AWS that's plugged into their backbone. There's a Megaport device, and those two have a cable between them. That's basically how that works, how Direct Connect works. It's a physical connection to the edge of AWS's network. So you're bypassing the public internet, you're connecting directly physically to the cloud provider's edge. So you're getting lower latency, consistent performance, guaranteed bandwidth availability, and also higher speeds. So Direct Connect is available up to 100 gig per second. And you do get lower costs as well. So because you're not using the internet, you're not relying on the internet, you've got this physical cable between you and the cloud provider. the cost to transfer data is substantially less as well, because you've kind of got this dedicated circuit you can use. So to dig into Direct Connect a little more specifically, basically there's three main components or types of components that make up a Direct Connect service. So the first part is the connection. A connection is the physical link, the physical kind of point on the edge of AWS's network that's dedicated to you. So it can be a dedicated physical cable that's just dedicated to you, or it can be a physical cable that is a hosted service from a provider where there's multiple VLANs on top of that. So either way, the connection refers to that layer 1 and 2 actual connection point at the edge of the AWS network. So when you see connection, and you'll see this in the AWS console when we click through it shortly, that connection construct, it refers to this physical point at the edge of AWS's network that you're plugged into. So on top of that connection, you create a virtual interface. So this is the next network layer up. So connection represents the layer 1 and 2 components of the link. The virtual interface represents the layer 3 components. So the virtual interface is created on top of the connection, and the virtual interface is where you'll do things like specify the IP addresses for either end of the link, specify the BGP configuration, and specify what it connects to on the AWS side. So if you imagine this like two switches or two routers that you want to connect to each other, you get a cable, you plug in each end, and that's kind of the connection. And then you'll connect to those routers and you configure the IP address on those interfaces and BGP, and that's the VIF. So that's how those two components fit together. So a VIF basically, for the most part, connects to a gateway in AWS when it's a private VIF or a transit VIF. There are also public VIFs, which connect directly to the AWS public edge to give you access to things like S3 or DynamoDB directly via public IP addresses and public routing. But for either private VIFs or transit VIFs, so that's where you want to use this service to connect into VPCs, into your private resources in the VPC, so into your EC2 instances and so on. You would use transit VIF or a private VIF, and those connect to a gateway. So that's the third component here. So the gateway is the thing on the end of the VIF, right? So it's if you imagine that scenario again with two routers or switches connected to each other, you've got the cable between, which is the connection. You've got the IP and BGP configuration, which is the VIF, sort of the interface, the layer 3 interface, and then the actual router that is an interface of is the gateway. So in AWS, you can either connect a Direct Connect VIF to a Direct Connect gateway or to a virtual gateway. So there are two different options. So we'll have a look at the difference between those in a second. But those represent essentially the router on the AWS side of this link. And then on the other end, on the customer side, you'll have your router. So you'll have your device in your rack or whatever the case may be. That gateway, that router on the AWS side is what then connects you through to whatever it is inside of AWS. So connects you to VPCs, connects you to transit gateway, or whatever it is you're trying to reach. It's kind of the router on the end. So those are the three components and how they fit together. So this gives you a bit of a view. It's a little bit of a busy diagram, but this gives you a bit of a view as to how the whole thing works and fits together. So starting from the left-hand side, there's the customer equipment. So this is your router or switch or whatever it happens to be that you're using to terminate this connection. There's a cross connect in the data center, so a cable plugged into a Megaport port, and then Megaport provides a virtual cross connect from that port into AWS. On the AWS side, that terminates as a connection. So that's that first layer. That VXC maps to a connection on the AWS side. So that maps to essentially a VLAN on a cable that's plugged into AWS. And from there, in the AWS console, there'll be a VIF that essentially is a layer 3 construct on top of that connection that connects through to a gateway. So this is moving from left to right. So the BGP session then rides over the top of that whole thing, and you've got essentially a link where On the left-hand side, you've got an interface on your router with an IP address on it, probably part of a /30. Then on the other end, on the very right-hand side, you've got the gateway in AWS with the other end of that /30, right? So the other IP address in that same subnet. And between those two, there's no other IPs, there's no other hops. It's directly between your equipment and the gateway in AWS. And then on top of that, that BGP session is created again directly between your router and then the gateway in AWS. There's no other bits in the middle. There's no sort of Megaport hops or IPs or BGP or anything. It's a direct connection straight into that AWS gateway, directly between your device and the gateway. So there's a couple of different gateways, a couple of different ways you can build this out inside of AWS. So basically all of these use a direct connection, and we're now just looking at the part inside of AWS. So essentially the customer, in these three separate diagrams, the customer would be off to the left, Megaport would sit between the customer and AWS, and then this basically gives you some detail about what happens from where you hit that AWS edge to how do you actually get to your resources. This is just looking at private resources. So this is just looking at essentially how you get traffic into your VPCs and whatever resources are in those VPCs. As I said, can be EC2 instances, but it can also be things like load balancers or other managed services. You can have Lambda attached to a VPC. You could have things like gateway load balancer or interface endpoints, whatever it is that's inside of these VPCs, basically. So if we start at the very top left, this is the first way, I guess. This is probably what we might realistically start calling the traditional way, or maybe even legacy, depending on your use case. But certainly this is the first option. And this top left option basically shows direct connect with a private VIF. The private VIF connects directly to a virtual gateway, a VGW, which you may have seen in the AWS console. It's the same type of gateway you'd create if you want to create VPN connections. So that VGW that's attached to one VPC, that can have a direct connect private VIF connected directly to it, and then it's attached to a VPC. So this allows your direct connect connection to have a path and route into this one VPC. As you can imagine, a lot of people have more than one VPC. And there's other scenarios like maybe you've got multiple direct connect connections in different locations and you've got multiple VPCs and you've kind of got stuff all over the place. So AWS introduced a new service quite a few years ago, probably 5 or so years ago now, called Direct Connect Gateway. And so if you look at the bottom left picture, this shows where Direct Connect Gateway can fit in. So essentially it can terminate the VIF. So instead of the VIF being directly connected to a VGW, a virtual gateway, the VIF can be connected to a direct connect gateway, and then the direct connect gateway can be connected to up to 10 virtual gateways. And then each virtual gateway is attached to a VPC. So this means you can use your one direct connect VIF to connect into up to 10 VPCs. So it simplifies things a lot. It means you don't have to have separate direct connect, separate VIF, separate everything for every single VPC. You can have this gateway in the middle, and it can kind of manage routing between potentially multiple direct connections, VIFs, and potentially up to 10 VPCs. So this makes it a lot easier, a lot more straightforward, and realistically, almost always now people use Direct Connect Gateway. It's a free service. It's kind of inherently highly available and managed, so you don't really have to worry about it. You don't really have to think about it too much. You basically just spin it up, and it's typically you'll never go and look at it again. It'll just do what it does, but it gives you some additional flexibility. It can simplify your designs, especially when you've got multiple VPCs. So the even more recent option is the one on the right-hand side. And this is where AWS introduced Transit Gateway. So although Direct Connect Gateway is very useful in that it can allow you to connect up to 10 VPCs to some number of Direct Connect VIFs, one VIF or more. Some people have more than 10 VPCs, and Direct Connect Gateway is really only to connect VPCs two Direct Connect services. You can't actually route through the Direct Connect gateway you can't route from one VPC to another, basically, through the Direct Connect gateway. It's only to go between Direct Connect and VPCs, not between one VPC and another. So AWS introduced another service, which is Transit Gateway. Transit Gateway basically can sit between VPCs, and it does allow routing between VPCs. And the other thing it allows is up to 5,000 VPCs to be attached to it. So if you look at the picture on the right-hand side, we've got the VIF, same as before, connected to Direct Connect Gateway, same as before. But the Direct Connect Gateway, instead of connecting directly to VGWs, the Direct Connect Gateway connects to a Transit Gateway, and then the VPCs are connected to the Transit Gateway. So this does a couple of things. This does allow control over routing between the VPCs. So you can use this to allow different VPCs to talk to each other through the Transit Gateway. So sometimes they can suit better than VPC peering. It gives you more control over traffic flows and routing and things like that. Then from the Transit Gateway, you can connect to the Direct Connect Gateway, and that also gives you control over routing. So you can choose which routes get advertised where, you can choose which VPCs can access the Transit Gateway, the Direct Connect Gateway, or other VPCs. You have a lot of visibility and granularity within that Transit Gateway about what routes go where and what can talk to what. And you can connect up to 5,000 VPCs to the Transit Gateway. So with Direct Connect Gateway, you could only have 10. With Transit Gateway, you can have up to 5,000. So it gives you a lot more scalability and a lot more control. Realistically, this is the design that we see most often now, is the one with Transit Gateway in the middle. Transit Gateway has been very popular, provides a lot of what may have been some missing bits and pieces in the AWS ecosystem. So even if you're not using Direct Connect, you may still be using Transit Gateway, and you can plug Direct Connect straight into that via Direct Connect Gateway. So Direct Connect Gateway is still in the middle. You can't connect Direct Connect straight to Transit Gateway. You have to have Direct Connect Gateway in the middle. So Direct Connect, the VIF terminates on the Direct Connect Gateway. The Direct Connect Gateway then has an association with the Transit Gateway in much the same way that a VPC does. All right. So we're going to jump into a demo. This is the Megaport portal. So first off, what we'll do is we'll create a port. And so you basically hit create port here. We'll choose which DC we want this port to be in. So this is the big list of DCs that we're available in. So we'll choose maybe an XDC, maybe S1, for instance. We'll choose a speed for the port. So we do 10 gig everywhere. We do 100 gig almost everywhere now as well. Give the port a name. Choose terms and things. Next and add. It's really straightforward. Basically, if as a customer, if I was in S1, I'd order a port in S1, and then I can just get a cable, get a cross connect from NextDC from my rack directly plugged into this port. So that's basically the process to order a port. Simple as that. This is all real stuff. This is all live services. So that's kind of really how long it takes to order a circuit delivered to your data center, order a port that you can plug into. So while that's deploying, typically it'll take 60 seconds or so to deploy that port. So while that's happening, we'll jump over to the AWS console and have a look around there. So this is the AWS console. This is the Direct Connect service within the console. So basically that's it's a top level service. So if you jump in the console, you'll basically be able to search for Direct Connect. You'll find this the same way that you would find, EC2 or CloudFront or Lambda or whatever. Direct Connect is its own top level service. And in here, you can see those constructs we talked about before. So you can see connections, you can see virtual interfaces, and you can see gateways, Direct Connect gateways, and virtual private gateways down the bottom, and also transit gateways. So these are all the components that we talked through before. So connections, as I said, this is sort of the underlying part, the layer 1 and 2 part of the service. virtual interfaces are created on top of the connections. So in this case, for hosted connections, each connection will have one virtual interface created on top of it. And then those virtual interfaces are connected to either virtual gateways or direct connect gateways. And if they're connected to direct connect gateways, the direct connect gateway then may be connected to a transit gateway. So that's how those things all fit together. This is how all these pieces show up in the AWS console. So let's see where this port is. So that port's finished deploying. It's ready to go now. You can download the LOA here to get the demarcation details, where to order the cross connect to in the data center. So you can plug into this port. But what we'll do is we'll go add a connection onto this port. We'll say we want to connect to the cloud. We want to connect to AWS. We'll choose hosted connection. We do support both hosted VIF and hosted connection. There's pros and cons, basically. Hosted VIF can be a little more flexible. Hosted connection, you can get some bigger capacities. Probably the biggest differentiator here is that hosted connection supports connecting to transit gateway. Hosted VIF doesn't. So there's some other pros and cons here that we can kind of talk through, but we do support both hosted VIF and hosted connection. And we do also support dedicated connections as well for customers that do need them. Realistically though, most of the time these days, customers will use hosted connection. So let's choose the on-ramp that we want to connect to. So this is the list of AWS on-ramps that we've got. So these are all the places where Megaport's physically plugged in to AWS. It's quite a big list all around the world. You can see here the latency between where you've ordered your port and this AWS on-ramp. So you can choose which ones are closest. We'll give this a name. Demo Direct Connect. Choose the rate limit for the service. So these are available similarly to the ports in 10 gig everywhere, and some locations higher than that. So some locations now support 25 gig, and as AWS rolling out larger capacity services, we're kind of moving with them. So we'll choose what VLAN we want this delivered as onto the port, because we do support multiple services all being delivered onto this one port. So if you've got a connection to Megaport, over that connection, you can bring up a VXC to AWS, also to Azure or Google, to Oracle, or to the internet, or to another data center, or other B2B providers, wherever else you might want to go. And those circuits are all delivered, those VXCs are all delivered to the port as different VLANs. So we'll choose that we want this particular connection to AWS delivered to our port as VLAN 100. So the next step is to provide the AWS account ID that we want this circuit to be delivered into. And we'll order the service. So what this will do now is it'll go and provision this as a point-to-point layer 2 circuit across Megaport's network from the port in the data center that's plugged into the customer device to a physical port elsewhere that we have that's plugged into AWS. So that's kind of how these pieces all fit together. So the port gives you a place to physically plug into Megaport as a customer. And then the VXC is a point-to-point layer 2 circuit from that port that's plugged into you as the customer to AWS, to their physical edge. So that's the second part we've created. When we created that service, you saw that we put in the AWS account ID, and that basically allows us to call the AWS API when we create this and have the AWS and map this service into your AWS account. So that's how this circuit ends up in the right place on the AWS side. So we'll jump over to the AWS portal again, and we can see now that we've got an extra connection that's come up here. So this is a hosted connection. We can see this additional connection, and you can see the status here on the right-hand side is ordering. So what that means essentially is that this circuit has been ordered. But as you saw, we just put in the account ID. And so we don't necessarily want to automatically connect this through. There needs to be a level of approval. If you jump into this circuit, you have the option here to accept the circuit. So that's how this workflow works. So step one, you go into the Megaport portal, you create the VXC that will create the connection in your AWS console. You come into the AWS console and accept the connection. Once that connection is accepted, see here it changes to pending, and then within a minute or two, it'll change to available. So once that circuit changes to available, then you can go into this circuit and you can create a virtual interface on top of this circuit, which is the layer 3 and BGP component. So when you create that VIF, you can choose whether you want it to be a private VIF, public VIF, or a transit VIF. So public VIF, as I mentioned before, is if you want to directly connect to the public AWS edge, you want to receive all their public routes, you want to do it all with public IP addresses, public ASNs, you want the 7,000 or 8,000 routes that compose all of AWS's public address space, because you want to directly hit public facing services, public load balancers, public S3 buckets, CloudFront, things like that, DynamoDB. Most of the time, customers want to connect into their private space, their private address space, so their VPCs basically. For that, you can choose a private VIF if you want to connect directly to a VGW connected to a VPC, or you want to connect to a direct connect gateway connected to VGWs connected to multiple VPCs. If you want to connect to a transit gateway, then you have to choose transit VIF. So that's essentially the difference here. So both of these are for private connectivity. Private is when you want to essentially use VGW to attach to your VPCs, including if you want to use direct connect gateway. Transit is when you want to use transit gateway to connect to your VPCs, which also requires direct connect gateway. So from these, if we choose private here, we give it a name, demo VIF. So that demo VIF runs on top of the demo DX connection. We want this VIF to be in our AWS account. We want to connect it to a direct connect gateway as opposed to connecting directly to a virtual private gateway. So up to you, just depends on the use case, as we looked at those 3 options earlier. We choose the direct connect gateway that we want to connect to. The VLAN we don't have to worry about. You just basically leave this because that's managed automatically between Megaport and AWS. You don't have to really deal with this VLAN at all. The one that shows up in the portal here, this is purely between Megaport and AWS. So you don't need to configure this VLAN on your switch or router or at all. You can kind of just ignore this part. We provide the BGP ASN of the customer router. And if we go into additional settings, we can also choose to provide the IP addresses and things. If we leave this blank, it'll generate some IP addresses automatically. So up to you whether you want to provide that. And then we can enable jumbo frames here as well. So Megaport does just natively support jumbo frames. If you do want to enable jumbo frames, you can just tick that box, and it just happens so long as you can configure that on your device as well. We may be able to create this, we may not. It may not have changed to available yet. We'll see how we go. Yep, looks like it is. So the VIF's been created, it's in the pending state. So basically that VIF will now be created, the layer 3 configuration will be done, the BGP configuration will be done, and it'll be connected through that direct connect gateway as we selected on the previous page. And that's basically it. If we click into this VIF, we can see the details here. We can see the IP address that AWS is assigned automatically. As you saw before, you can specify these manually if you want to. If you leave it blank, it'll just get automatically created. You can see the BGP key here, again, automatically created. You can specify it if you want. If not, it'll be automatically generated. And you can see up here the Amazon side ASN. So this will be the ASN of the Direct Connect Gateway in this case, but it depends what you connect it to. If you connect it to VGW or Direct Connect Gateway or through either way, basically, this is what you would have specified when you created the gateway. So it's not standard. Some of the other CSPs, it's always the same ASN. With AWS, the ASN is provided by you when you create the gateway, and you just match that to the gateway that you connected to. All right. I think we're actually basically out of time. So let me just have a quick look whether you had anything come through. No, not at the moment. Cool. All right. Well, yeah, that's basically the end of the session for today. As usual, we'll upload these to the YouTube channel afterwards, so feel free to go there and watch them. If you do happen to be watching this on YouTube, feel free to leave a comment. If you have any questions, we'll basically use those to drive what we do with future videos. If not, feel free to reach out to your account team if you've got any questions, or yeah, feel free to reach out via the website if you're not already a customer. And we will see you next time.